Hi, Professor. So, we are Straw Hat teams, and my team members are Mustaqim, Manpreet, and myself, Prabjeet. So, our today's agenda is methane emission by Syncrude. So, we will be starting with introduction, operational issues of Syncrude, root cause of methane emission, three technology solutions for methane reduction, the one recommended solution for them, the implementation timeline, the cost and expected result, the benefits and ROI, and a last conclusion. And introduction will be given by Manpreet. Thank you.
Good morning, Professor. I'm going to introduce Syncrude, which is a major player in the Canada's oil sand industry, and it is based in the Alberta. Syncrude is a joint venture between the Suncor Energy and ExxonMobil. So the company is dedicated to the bitumen extraction and processing. It mainly aims to produce the synthetic crude oil, along with balancing the economic interests with environmental responsibility. Now coming to the operational issue, our operational issue is the release of methane as a part of normal operation. It is one of the major issues that any oil company in the world is facing right now, as methane has a great potential of causing greenhouse effect over the other gases. So as we delve into the operational methods of oil and gas industry, we encounter various fundamental causes of methane emission. These include escaped emissions, intentional flaring and venting, absence of control and monitoring, technological restrictions, and industry customs. So first is the escaped emissions. Uh, uh, escaped, emi- Escaped emissions of the methane gas occurs during various stages of oil and gas production, that are extraction and distribution processes. So these emissions occur when methane is released into the atmosphere due to the leaks, malfunctions, or inefficiencies in equipment, infrastructure, and operational practices. So one significant source of escaped methane emission is fugitive emission, which occurs when methane leaks from the uh, equipments, pipelines, valves, and other components that are used in oil and gas operations. So these leaks can result from factors such as inadequate maintenance, aging infrastructure, equipment malfunction, or improper installation. So next is the flaring and venting. So flaring involves the burning of excess gas in a controlled manner. This is done during routine operations, equipment maintenance, or emergency situations to prevent the buildup of pressure in the oil wells or processing facilities. On the other hand, venting involves the direct release of gas into the atmosphere without burning it. So this process is typically used when it's not feasible or cost effective to capture and utilize the gas for the other purposes. So, so our third point is the technological restrictions. It refers to the limitations or challenges associated with the existing technologies for detecting, monitoring, and mitigating the methane leaks and emissions throughout the oil production and distribution processes. So reliance on the traditional leak detection methods that may be outdated or insufficient in accurately detecting the identifying methane leaks is a primary restriction. The methods such as manual inspections or handheld gas detectors, they may have some limitations in terms of coverage, their sensitivity, and their reliability. So leading this, all these leads to the undetected leaks and inaccurate emission reportings. So apart from this, the fourth point is the absence of control and monitoring. One of the main challenges is the absence of strict regulatory framework and enforcement mechanisms to ensure the compliance with the methane emission reduction targets and the set standards. So without clear guidelines and penalties for the non-compliance, companies may prioritize cost-cutting measures over investing in the emission reduction technologies and practices.
Hello. As Manpreet came up with some root cause of the methane leaks, we came up with some three solutions. The first is unmanned aerial vehicle, IoT sensors, and software for methane quantification and detection. I'll start with UAVs, unmanned aerial vehicles. These are the drones which are fitted with some sensors that will check the emission of methane into the environment. As drones are able to gather data on the sources of pollution in real time, as well as they are efficient in covering the big areas, so we will have the big amount of data, and as it is covering the wider range. Moving to IoT sensors, these are the equipments equipped with sensors that allow the real-time monitoring of methane levels. These sensors will gather data information, which they will wirelessly transfer for the analysis, and IoT sensors facilitates data-driven choices for reduction initiatives, enhances safety protocols, and optimizing the maintenance plan. It will help us to detect. It will help us to detect the early leak of methane, and so that we can take the actions accordingly. Moving to software for methane quantification and detection. Methane emission from syncrude activities are identified, measured, and shown using sophisticated algorithms in data analytics based methane detection and quantification software. To provide the picture of emission of methane, this software integrates with the current system for monitoring to evaluate data from variety of sources such as detectors, drones, and the satellite images that will help us to gather data and work accordingly. So here we come up with the solution that we recommend for the Syncron, that is installing the IoT sensors in the company. So it will help us to monitor the real-time data of the methane emission in the facility. This constant surveillance ensures that any changes in methane concentration are promptly detected and allowing for the immediate action to be taken. Second, data transmission. The sensors will collect data and transfer it for the analysis, and the rapid transmission of data enables the timely decision making based on up to date information about the methane levels. So it will help to act accordingly on it. Immediate input on gas level. One of the primary application of the sensors is to provide the immediate input on methane level by alerting the facility operators to work on it. It will help us to change the methane concentration as they occur. These sensors are enabled for proactive response, and it has a very less amount of the errors. Detection of leaks. IoT sensors aid in the early detection of methane leaks by continuously monitoring the methane levels. These sensors can detect the leak as soon as they occur in the facility, allowing the immediate action to be taken, and repairs can be made before the leaks can happen. And next to Mustaqim.
Hello, Professor. Here's the timeline for implementing IoT sensors for ongoing methane level monitoring at Syncrude's facilities. Over a 10-month period, we will implement IoT sensors to monitor methane levels at our facilities. In the first 2 months, we will define objectives, identify high-risk areas, selecting sensor technologies, and we will secure funding. Months 3 or 4, we will focus on designing sensor layouts, pro, uh, procuring equipment. During months 5 and 6, we will install sensors, calibrate them, and establish wireless connectivity. Next, in months 7 and 8, we will integrate sensor data, conduct testing, and fine-tune software for optimal performance. Months 9 and 10 involve training staff, implementing response protocols, and deploying the sensor network. Finally, ongoing monitoring and optimization will ensure continuous improvement in safety and efficiency. The structured approach ensures a comprehensive and efficient deployment of IoT sensors for methane monitoring. So at Syncrude, we are making a smart investment in safety with IoT sensors. We are looking at initial investment of 130K to 150K dollar, covering sensor procurement, installation, software development, and integration. Once installed, we will spend around 20K dollar each year on maintenance and calibration to keep the sensors accurate and reliable. These sensors will help us detect methane leaks faster, making our workplace safer and saving us money in the long run by minimizing downtime and potential hazards. In short, it's a small investment now for big safety benefits and long-term savings. So our expected result is less methane emissions, means a safer workplace and compliance with regulations. Also, smart monitoring leads to quicker leak detection and minimizing downtime, also potential hazards. Data-driven decisions help optimize maintenance schedules, saving cost in the long run. In short, investing now means safer operations, fewer disruptions, and long-term savings. So beyond just monitoring methane levels, these sensors offer numerous benefits. First one is improved reputation. By taking a proactive stance on environmental management, we are not just meeting regulations, we are setting standards for responsibility industry leadership. Second one is future proofing. Our investment in IoT sensor technology isn't uh, just for today's regulations. It's preparing us for whatever the future holds. As regulations evolve, we will be ahead of the curve. And the last is data insights. The data collected from this sensor isn't just for compliance, it's a treasure trove of information that can drive continuous improvement in our operations. And when it comes to ROI, the benefits are clear. We are mitigating risks and protecting our assets by detecting methane leaks early, potentially saving us from costly accidents and repairs. Compliance isn't just about avoiding fines, it's about maintaining our reputation and competitive edge. And let's not forget the cost savings, decreased downtime, lower maintenance expenses, and a more efficient operation overall. So, in conclusion, let's talk about what all of this means for Syncrude. By investing in IoT sensors for methane monitoring, we are not just making a smart business decision, we are making a statement about who we are as a company. We are showing that we take safety seriously, that we care about our environment. And the best part is, it's not just a talk, it's action. We are looking at real savings, real reduction in emissions, and real improvements in how we can run our operations. By embracing this solution, we are setting ourselves up for success in a world that's always changing. So let's move forward with confidence, knowing that we are not just leaders in our industry, but leaders in sustainability, responsibility, and innovation. And last but not least, in the next slide, you can see the references as well.